All right, let's jump right into this explainer. For a long time, organizations have been completely obsessed with looking in the rearview mirror, just trying to capture what already happened. But today, we're shifting gears. We're talking about predictive analytics, a totally fascinating area of data science that allows companies to essentially forecast the future. So, can businesses actually predict the future? I know it sounds a bit like science fiction, right? But it's actually highly sophisticated mathematics and computer science at work. Think about it. Every time we make a decision in our day-to-day lives, we naturally think about what happened in the past to guess what'll happen next. Businesses are just doing this exact same thing, but at a massive automated scale. They're not just reacting to yesterday's news anymore. They're actively calculating tomorrow's opportunities. To really unpack this, we're going to break things down into 4 areas. What predictive analytics actually is, how it works under the hood, the advantages and disadvantages, and finally, some real-world industry examples.
Okay, starting off with section 1. What exactly is predictive analytics?
Well, to really understand it, you've got to compare it to descriptive analytics. Descriptive analytics is your basic data analysis. It focuses exclusively on previous historical data, just collecting and presenting what already happened without making any leaps or inferences. Predictive analytics, on the other hand, just like the name implies, it actively focuses on forecasting what might occur in the future. It analyzes past data patterns and customer insights to not just report the news, but to predict the weather, so to speak. And honestly, this is a total game changer for business operations. By analyzing those past patterns, executives and managers can take a much more proactive, data-driven approach. Instead of just guessing, they're using these forecasts to set realistic goals, execute highly effective planning, manage performance, and, maybe most crucially, avoid some pretty massive risks. It lets them foresee customer behavior, spot sales trends, and forecast inventory demand before a bottleneck ever even happens.
Moving on to section 2. How does it actually work?
Okay, so the absolute foundation here isn't a crystal ball, it's math, specifically probability. Predictive analytics is constantly trying to determine the likelihood of possible future outcomes. When a prediction is needed, machine learning algorithms look at the current data and literally just make the best, most feasible mathematical assumptions to fill in the missing blanks of what hasn't happened yet. To make these probability-based predictions happen, data scientists lean heavily on 3 core techniques. First up is data mining, which is organizing and filtering massive data sets. Second is statistical modeling, which looks for the mathematical relationships between different variables. And finally, machine learning algorithms. We're talking classification, regression, and clustering techniques. These algorithms build models based on training data, meaning they adapt and get smarter and smarter over time.
And that brings us to deep learning, which is this incredibly powerful, newer subfield of machine learning. The best way to describe it is thinking of human brain networks as layers of nodes that understand a specific process area, but are networked together to provide an overall forecast. It literally imitates the structure of our own minds. By networking together, these layers process unstructured data and completely automate a lot of the heavy lifting. You can see this deep learning methodology applied in some seriously complex scenarios. For instance, it's used for credit scoring, analyzing social and environmental data to figure out if someone is a reliable borrower. It's even heavily utilized in medicine, sorting through digital medical pictures like X-rays to generate automated predictions that actually help doctors diagnose their patients. All right, let's jump into section 3, the advantages and disadvantages.
Now, we have to keep in mind that because this is all based on probabilities, it's never going to be 100% precise. The system is making highly educated guesses, but they are still guesses. Plus, you need an enormous quantity of historical data for this to work. A tiny data set just isn't going to cut it. But even with those limitations, the benefits are undeniable. It serves as an absolutely crucial forecasting tool and has become a primary driver in forming future corporate strategy.
Despite the limitations, this incredibly enhances day-to-day business functions across the board. It supercharges organizational effectiveness, like nailing your inventory forecasting. It totally transforms customer service by helping businesses gain a deeper knowledge of who their clients are, so they can easily personalize suggestions. It's massively relied upon for detecting and preventing fraud, and it's absolutely vital for risk mitigation, like doing enhanced applicant screening in the financial sector before extending any credit.
Which leads us perfectly into our final section, section 4, real-world industry examples. The healthcare business is actually a major benefactor of predictive analytics. A really profound example of this happened in 2019. RMIT University teamed up with the Digital Health Cooperative Research Center to build clinical decision support software specifically for aged care.
By analyzing historical data, this software actually predicts patient deterioration. The goal here is to reduce sudden emergency hospitalizations and, most importantly, give senior care professionals and families the time they need to better prepare for end-of-life care. It's a truly striking example of data science providing tangible, compassionate value. But beyond aged care, this stuff is revolutionizing pretty much every sector you can think of. In e-commerce, algorithms are anticipating exactly what you want to buy based on your past search histories. In sales, models are estimating the exact likelihood that a buyer will add another item or just leave the shop. Over in human resources, they're rapidly identifying employees who might be thinking about quitting, allowing management to step in and urge them to stay. IT security uses it to instantly detect potential vulnerabilities, and hospitals are even using it to accurately anticipate their future staffing and resource needs. So, as we wrap up this explainer, it's pretty clear that the organizations mastering tomorrow are the ones deeply analyzing their yesterdays. The algorithms, the neural networks, the probabilities, they're all just tools to unlock the stories hidden in massive data sets. So, I want you to take a look at your own organization's data footprint, or even just your personal data trail, into the absolute peak of data-driven strategy. If you deal with business data at all, you already know that collecting information is really only half the battle. The real magic? That happens in how you actually use it. I want you to imagine having a system that doesn't just warn you about business uncertainty, but actually urges your firm to action. We're living in an era where businesses are practically drowning in data, but they're often starving for actual direction. So what if your data could shift from being a simple rearview mirror to becoming a highly advanced strategic GPS for your company's future? Here's our quick roadmap for today. We'll cover the business analytics ladder, define prescriptive analytics, break down outworks, compare predictive analytics and machine learning, weigh the pros and cons, and finally look at some real-world applications.
Section 1. The business analytics ladder. Think of data analysis as a 4-step journey. First, we have descriptive analytics, which simply describes what has occurred. Second is diagnostic analytics, exploring exactly why it occurred. Third, we step up to predictive analytics, which forecasts what could occur. And finally, we reach the summit, prescriptive analytics, which dictates what should be done. That is where the real power lies. Moving right along to Section 2, defining prescriptive analytics. Prescriptive analytics is the fourth, final, and without a doubt the most sophisticated step of the entire business analysis process. It goes a massive step further than just descriptive or predictive analytics by actually advising on the best potential actions. It literally urges firms to action. It assists executives, managers, and operational folks in making the absolute most informed decisions possible based on the available data. To put this into perspective, think of everyday GPS technology. A standard map? That's descriptive. Traffic alerts, those are predictive. But a GPS that optimizes your goal by analyzing the distance between your origin and destination, factors in travel time and road closures, and then prescribes the ideal path with the least distance, that is prescriptive analytics in action. Section 3. How does it work? So, how does this actually come together? Well, it needs significantly more specialized analytics expertise to execute, which is exactly why it's rarely utilized in basic daily company operations. It takes accessible internal data, pairs it with external data, like what we see on social media, and then applies a multitude of tools, like rules, statistics, and machine learning algorithms. It analyzes the potential repercussions of every single choice alternative. This enables decision makers to assess the consequences of each future outcome before they even make a choice, capitalizing on future opportunities and reducing hazards. And honestly, the capabilities of the machine learning used here completely dwarf what any human could achieve trying to get the same outcomes. Section 4. Predictive versus machine learning. Now, there is a widespread misconception that predictive analytics and machine learning are the exact same thing. They definitely aren't. Predictive analytics uses historical data and statistical techniques to predict what, when, and most importantly, why something may occur. Machine learning, on the other hand, is a computer system's ability to understand massive, often enormous amounts of data without explicit instructions. It adapts, it becomes increasingly intelligent over time as a result. You can clearly see how these concepts nest together. Machine learning is actually a specialized subset of artificial intelligence. It's this adaptive intelligence that really powers prescriptive analytics, taking it way beyond traditional statistical modeling. Section 5. Weighing the pros and cons.
Let's start with the advantages because they are huge. When utilized correctly, prescriptive analytics provides incredibly important insights for making the most optimal data-driven decisions. It can totally transform corporate strategy and performance. We're talking about enhancing production, elevating the customer experience, and driving overall business success. Plus, because it relies so heavily on machine learning, it significantly minimizes the likelihood of human error. But it's not a magic wand. There are definitely disadvantages. Similar to predictive analytics, this technique requires enormous volumes of data to deliver effective findings, and that kind of data just isn't always available. Also, machine learning techniques simply cannot consistently account for all the unpredictable external variables out there. And as we touched on earlier, it requires significantly more specialized analytics expertise, which can be a huge hurdle. Section 6. Real-world applications. Let's look at this out in the wild. In healthcare, it's actively enhancing patient care and administration by analyzing readmission rates and evaluating the cost-effectiveness of operations. In pharmaceutical research, it's a real game changer for determining the absolute optimal testing methods and pinpointing the exact patient populations needed for clinical trials. In the oil industry, it's used for closely monitoring price fluctuations. Over in manufacturing, it's enhancing everything from equipment administration and maintenance to cost modeling, production, and storage. And for insurance providers, it accurately evaluates customer risk in terms of price and premium information, helping them perfectly balance risk and reward.
So ultimately, you have to ask yourself a critical question. Is your organization stuck in the past, just describing what already happened? Or are you ready to prescribe exactly how to win the future? The organizations that thrive tomorrow won't just be predicting the future, they'll be letting data prescribe their exact path to business success.
Today, we are unpacking a really vital topic, the standards for data tagging and reporting. If you've ever wondered how messy, completely disparate business data gets magically, technically transformed into standardized, universally readable digital formats, you are absolutely in the right place. We're going to take a close look at the specific technologies that literally make modern digital finance and global data sharing possible. Okay, let's dive into this, because it's the fundamental challenge of modern business. Imagine two entirely different computer systems. They're sitting on opposite sides of the world, built by totally different developers. How do they actually share information? Well, in order for these dissimilar systems to exchange data without a cascade of errors, they first have to agree on a specific file format.
You see, if we just rely on traditional text documents, we have something that's perfectly human-readable, but it's a total parsing nightmare for a computer. On the flip side, arbitrary data structures that are built specifically for machines can be completely incomprehensible to a human analyst. What we desperately need is a standard that bridges this gap. We need a standard that encodes text in a format that's easily understandable by both humans and machines, finally eliminating all that chaos caused by incompatible software.
So here is our roadmap for the explainer today. First, we'll look at the data communication challenge. Second, unpacking XML. Third, the mechanics of tags. Fourth, introducing XBRL. And finally, number 5, the benefits of digital reporting. Let's get moving!
Section 1. The Data Communication Challenge. Bridging System Gaps.
The core of this whole communication challenge really comes down to a procedure called serialization. Basically, serialization is the primary function you need to store, send, and rebuild arbitrary data across completely dissimilar systems. When you send a massive, complex financial report across a network, the data has to be flattened out. Actually, scratch that. It's more like it gets disassembled, transmitted, and then perfectly rebuilt on the other end without losing any of its intrinsic meaning. We absolutely have to have a standardized procedure to normalize this entire process.
Which brings us to Section 2, Unpacking XML, the Universal Translator. Enter XML, or Extensible Markup Language. Defined way back in the 1998 XML 1.0 specification by the World Wide Web Consortium, XML is a standard file format and markup language. And the best part? It is completely built on free, open standards. What makes XML so incredibly powerful is that it's a textual data format with significant support for many human languages through Unicode. It really acts like a universal language for describing information.
Now, XML was built with 3 major design objectives in mind: internet usability, universality, and simplicity. Even though its architecture is centered around text, XML is universally used to express arbitrary data structures, like the ones employed all the time by web services. It's explicitly designed to be simple, highly effective, and usable across the entire internet.
Section 3. The mechanics of tags. Let's look at systematic arrangement.
And this brilliantly illustrates how it actually works under the hood. As a markup language, XML systematically labels, categorizes, and arranges information using tags. These XML tags represent the data structure and contain the information itself, but it doesn't just stop there. A supplementary XML schema, often known as XSD or the canonical schema, defines the required metadata for reading and verifying that XML. This creates two distinct quality checks, right? A well-formed XML document simply complies with fundamental XML principles, but a valid document, that one rigidly adheres to its specific defined schema.
And to ensure this data travels securely in a networked setting, there are some pretty rigorous technical criteria in place. Documents like IETF RFC 7303 specify media types, such as application/XML, for transferring unmodified files without revealing their intrinsic meanings. Meanwhile, RFC 3470 provides comprehensive recommendations for building and implementing XML safely in networked environments. It's the technical bedrock that keeps everything running smoothly.
Moving on to Section 4, Introducing XBRL. Welcome to Digital Reporting.
Now, what's really interesting here is how we take the universal alphabet of XML and turn it into a highly specialized business dialect. Meet XBRL, the Extensible Business Reporting Language. This is a data description language based entirely on XML. It facilitates the automated interchange and the trustworthy extraction of corporate and financial data across literally all software types. It is a total game changer.
The basic idea behind XBRL is replacing plain content with rich context. Think about it. Instead of treating financial information as just a block of text or raw data floating around aimlessly on a page, a unique electronic tag is attached to every single individual item. So when a piece of data is labeled as revenue, XBRL-enabled applications definitively know, without a doubt, that it pertains to revenue. It can even expand that context by designating a specific number as currency or accounts. It's not just content anymore, guys. The context travels right along with it.
The source material offers this brilliant analogy that really hits the nail on the head. The change to XBRL is like the change from film photography to digital photography, or from paper maps to digital maps. By going digital with XBRL, you can still do everything you used to do, sure, but you open up fundamentally new capabilities. The information becomes platform independent, perfectly testable, and infinitely easier to share, analyze, and add real value to.
If we map out the whole XBRL ecosystem, you'll notice how internal business operations connect seamlessly all the way through to external reporting and investment analysis. Whether we're talking about general ledger, journal entry reporting inside a company, or tax and regulatory filings aimed at regulators and investors, XBRL acts as this standardized, unified pipeline. Software vendors, auditors, management accountants, and data aggregators, they are all operating on this single interchangeable standard.
Finally, Section 5, Benefits of Digital Reporting.
So the crucial point is, why do all this? Well, the benefits of adopting XBRL are absolutely massive for any organization. First, automated processing. Because reports are generated from a single source of truth, it drastically reduces manual data entry errors and boosts overall reliability. Second, testable business rules. You can build logical constraints directly into the system, meaning poor quality information is caught in the draft stage before it ever reaches a regulator. Third, multilingual support. Tags can be automatically translated, which opens up financial reports to a global community. And lastly, interchangeable data. Information flows like water across completely different organizational systems.
I want to leave you with this final provocative thought to reflect on regarding your own organizational practices. Is your data just raw content floating on a page, or does it have true context? By leveraging the power of XML and digital tagging through XBRL, modern businesses are definitively answering that question and completely revolutionizing the way they report, share, and analyze information. Thank you so much for joining me.